never gonna get patched. There's no proof of it. And even if there was proof of it, the most you'll ever get is probably.
All right, let's open up to page 67. Yep, back to tables.
That's even easier.
Well, we're going to step it up a little bit. So yesterday we were looking at domain, and I think yesterday went really well. Okay, we started to take a look at domains and how we can analyze them without having a graph, like certain things we can look for in an equation. We are going to take a break from domain just very briefly for this section, but we're going to come back to it in the last section of the unit, okay, 1.7. In this section, though, for 1.6, we're going to talk about composition of functions. And very similar for you musical people in here, when you compose a piece of music, you normally bring in different instruments, like in an orchestra, to make that piece of music sound a little bit more interesting. So composition is when you're bringing different things together to create kind of something new. In our mathematical sense for today, we're going to compose functions. So we're going to bring functions together to create something new. Okay, a new equation, a new value, whatever it might be. Now, on page 67, we're going to start things off kind of simple with a table of values where we just have a bunch of different numbers given to us. And it's a larger table of values because it's representing 3 different functions. We have the f, the g, and the h. So a lot of numbers going on, might get confusing, but we got to keep them nice and organized. We've already done composition functions a little bit this year. For instance, if you take a look at A, B, C, and D, we've discussed what those notations are telling us to do, okay, what it's asking us to find. We may not, however, be familiar with the notation in letter E through L. Okay, those can be a little bit trickier because they might be something new to us. So we're going to start things off kind of simple here. I'm thinking we can just do the first one together, and I'll let you do the other 5 by yourself, just because we've already done this year. But as a refresher, we need to figure out what h of 0 is based off the table. So that 0 is representing your x value, meaning your input. So if we plug in 0 into the h function, notice how we would get 2. Make sure you are using the correct function, because if you're not, you might have an incorrect variable, or value rather. We then have to multiply that number by g of -3. So input of -3, the g function would give us -2. So we have -6 times -2, which would be +12. Okay. Do you guys think you can do B, C, and D by yourself? Go ahead and give them a shot. We ready to check, or do we need a little bit more time? We're good? All right. How about 14/3 for B? Good? 20 for C? And 0 for D? Perfect. Okay, do we got to talk about any of those three? No? Awesome. All right, let's take a look at E. We have not seen this function notation this year, but you may have seen it previously in a past math class. Not sure. That's why I want to go over it together. Can we either recall, if you've seen this before, what it means, or if you've never seen this before, can we think about what it's asking us to figure out? Can you look at the way it's written and interpret what it is saying? Bless you. Can we brainstorm some ideas? What do you think, Noah?
F at -2 and then whatever that is, then you do an H of that.
H of that. Do you kind of see, based off the way it looks, that the F function is inside the H? See how it's inside the parentheses? So this is a different operation that we're able to do. You're used to adding, subtracting, multiplying, and dividing. Those are the more common operations mathematically. But this is what's referred to as a composition, I guess, because you're combining two things together. But you're putting one answer inside of a different function. So we're initially starting with an input of 2, and we're going to plug that into F. So based off the table, F of 2 is 3. But now that answer of 3 is your new input for the H function. So if you were to input 3 into the H function based off the table, we'd get -1. You see how it's not necessarily adding, subtracting, multiplying, or dividing. Okay, it's a new operation. You're taking one thing and plugging it into a different item, okay, a different function. Do you guys think you can try the rest of them? They start to get good for J, K, and L. Okay, give them a shot. See how you do. I'll be walking around and double checking, and then we'll check them out together.
I like dogs. Excuse me. Oh, I looked at the wrong thing. 0 and then G0 is No, I looked at G instead of looking at H, so then I got 5. I was like, oh, Karen, how do I find G of 5? G of minus 3. Minus 2. And then F of minus 2 is 3. And then G of 3 is minus 3. H. Actually, I just almost fractured my foot in gym before. Well, so I was running, I fell in Jenna South, all of a sudden starts running and then stops right in front of me. I moved, and I almost ran into it, so I had to jump over here and like landed on my foot. I was tempted to run. She got me caught.
If that, actually, then what about it?
I got hit.
I'm always tired.
Yesterday.
That's why I'm always Alright, G3.
Yeah, that's why you injured neck punctuation.
If you're feeling better, because you know last week.
This one is ever so slightly.
Owie.
No, I fell and got like scraped.
There.
There's a mark out there. So
It's hurting. Gas.
yeah, it's right.
Scrape.
Backpacks and stuff and just kept it.
Shoulders.
That was yesterday.
I was in gym and I got kicked with a soccer ball.
So,
Maybe next time.
Yeah, let's hope so.
Alright, let's check them out. -2 for F. -3 for G. 5. 0. 1/2. -2. -3. I walked around and they were looking really good, but I didn't get the chance to look at everybody's or every single problem, so check and see how you did. We hanging in there? Yeah? Okay. Let's go ahead and relate these to some function notation examples we've been seeing so far this year. Look at M. If the K equation is 2x plus 10, we're going to solve for x that makes this statement true. Okay, function notation can get a little confusing. We just got to think about what does each piece mean. So when we look at this, notice how the left-hand side is K of x. That is representing the equation they gave us. So we can go ahead and write that in its place. Next comes the equal sign. And on the right-hand side, we got to figure out that craziness. All right, but you guys had no problem with the last examples, so I think we should be able to figure this out. If you were to plug in -1 into H, and then that answer into G, and then that answer into F, what would we have? Can we find it? Yeah? -4. I like it. Let's check it out. We got to plug in. I'm going to move up to the top for a second. We got to plug -1 into H, which our answer would be 1. Then we got to take that answer of 1 and plug it into G, which will give us 0. And then we got to take that answer of 0 and plug it into F, which will give us our final answer of -4. Okay, so that one was very similar to the J, K, and L that you did previously, where you had 3 of them to do. So there's our setup based off of this notation. We should be able to solve for x from there. We can subtract 10 and then divide 2. All right, let's check out N. If P of x is the absolute value equation, solve for x that would make this statement true. So on the left-hand side, P of x, we can rewrite that as the equation they gave us, and we want to set it equal to whatever this function notation is representing. So on the table, we got to plug in -2 into G, and then take that answer and plug it into F. What would we get? Yeah. 4. All right, so here's our equation. We want to solve for x. Where do you want to go from there? What do you think, Hadley? Close. You have the right idea of breaking it up. Okay, this is going to be 2x minus 3, and that would equal a positive 4. And then a 2x minus 3 would equal a negative 4. Okay, she had the right idea of needing two things. So solving for each one, we can, let's see, add the 3, divide the 2, so we'll get 7 halves. And then for the other one, if we add the 3, divide the 2, we'll get negative a half. We doing okay? We're going to change it up a bit. We ready for it? Oh, yes. All right, take a look at the next page. Very similar type problems, but notice how the information we have is a different format. Instead of having a table to like bounce back and forth off of with the values, we now have graphs. So it still works the same way, okay? These function notations are still operating the same way they did before. It's just that we have to analyze a different piece of information. This time it's a graph instead of a table. I think you guys can do these on your own. Go ahead and try A through L. Okay, use the graphs.
Well, okay, so these are values to the yes. I thought so.
It's not garbage. It's paper.
Minus 3. Ooh. Thank you, Robert. Bless you. Oh, shut up. I said it first. Still everything. It's not going to be something. What? Actually, no, I did say one. That's for my dad. He actually gets sick really a lot. No one asked. No, I did. Minus G of minus 3. Get minus 2. Can you like get out of here? He just left. Yeah, I'm right. He like goes out and starts. He starts dancing by the way. Oh, can you take a picture of Carter? Carter like on his arm. Let's see. Please, can you ask Carter to do that? I haven't done the project in a while. What did you do, please? How am I supposed to do that? Should I just bring him a deck of bingo cards just so he can... Yeah, it's right. And then I have to have him arrange it so then he can show me your waves. Please. That's so much fun. I know. Minus 1. G minus 1. Yes. G of minus 2 is 6, and then G of 6. No problem. 2 times 6 is 12. G of minus 3 minus 2, and F of minus 2 is minus 1. I'll wear it out. What's this number?
It looks like Mark's
Why do you think saying, like, I say minus 1? I don't understand why you want me to say negative. This is what I mean. They're essentially the same thing. They're the same thing. It's just minus 1.
It's because whenever you answer a question, you're like, yeah, that's like a minus 3 or negative 3.
This is how we always are. G of trace is 1.
Okay, you also stop showing work. When did I start? I kind of start showing work. Kind of stopped. Yeah, I wrote a 0 there and just kind of. I wrote a 2 there. So did you? I wrote that one. I wrote one. I know. Sometimes. Maybe.
Just F1. You add 2 to 0. G of 0 is 2. F of 2 is 2. Ready? Down. Stop. 1. F of minus 3.
Yours here has been F here every day.
G of 1 is minus 1. That was actually an accident. That's not. And G of negative 1.
Oh, it's not. It's not value. It's an absolute value.
Okay.
No.
Wait, do you want us to solve these ones?
No.
There was
All right, let's check him out. Again, we looked good as I was walking around, but double check just in case I was not able to look at all of your answers. Two thumbs way up. Looks good? We got to talk about any of them? We're good? All right. Let's check out the two at the bottom. So these solving ones. H of x equals g of f of 1. They tell us the h of x equation, x squared minus x, so we can write that on the left-hand side. And on the right-hand side of the equal sign, we got to figure out g of f of 1. So if you're to plug in 1 into f and then plug in that answer into g, what would we get? Go ahead, Hedley. 2. All right, so somehow we got to solve for x, find the values of x. How do you want to do that? Yeah. Factor. Okay, that little power of 2 I'm hoping is like a little light bulb going off in your head saying factor, factor. So in order to factor though, we need it equal to 0. That way we can solve. So we'll subtract the 2 over. Thinking about your techniques, this fits what I call the I am profile because our a value is 1. So we got to think about two numbers that multiply to -2 but add to a -1. Yeah? There we go. -2, +1. So if those are the factors, then solving for x, we would get a +2 from the first factor and a -1 from the second. Looks good. Let's try n. So we want p of x, which is the absolute value equation they give us, equal to f of g of -2. So using the graphs, if you plug in -2 into g and then that answer into f, what do you get? Good, Hedley? -2. All right, how do you want to solve for x from there? Yes? Divide the 3. All right, then yes? Split it into 2. Maybe. Because that's what we did on the last one, right? Okay, so your brain, I need everyone to listen up. Your brain has been programmed very well, I might add, that whenever you see an absolute value, to break it up, because you're most likely going to have two solutions. Why can we not do that for this one? You get into a groove every single time, but this one you can't do it. Why? What do you think, Carter?
Absolute values can't be negative.
Absolute value cannot be negative. Notice how this statement is telling you if you were to plug in a number for x and then take the absolute value of it, your answer should be a negative 2/3, right? If you take the absolute value of something, its result will always be positive. There's no way it can be a negative. So you might get into the groove of breaking things up. And if you did that, you would still get answers. Okay, but if you actually checked them, plugged them back in, they would not make sense. So we'll say this one has no solution because an absolute value cannot be negative. Okay, we got to be a little careful and aware of what the equation is telling us. Okay, what it looks like. Does that make sense? I hope. All right. Let's try some more. So we initially looked at a table, then we just finished looking at graphs. Let's check out a few on the next page that are functions now. Okay, some different piece of information that we know. It might not always be a table, it might not always be a graph. So let's check out one. It's the same notation, g of h of a number, but this time we're going to use the functions to actually calculate our value. So if we were to plug in 4 into the h equation this time, which is given at the top, let's see what we get out. 3/2 times 4, or 1.5 times 4, however you want to think about it. That would be 6. Okay. Minus 2, we get 4. So we got to take that answer and now plug it into the g equation, which is also at the top. So 1 minus 8, we get -7. Okay, it's the same principle, it's the same concept, but we're using a different representation. Instead of a table or a graph, now we have an equation. Do you guys think you can do the next two? Yeah, give them a shot. Try 2 and 3.
I'm on my side. On your side, on your side.
It might just want us to
Oh, they're telling me to assume, or they're telling me to suppose things.
you get final expression.
Oh, you get a 0.
For which?
Second one.
Look immediately right there where it's 5 over 2.
What is the number?
Yeah, what is the number?
Minus under 3.
Yeah, minus 3. No, you can't get out of here.
And they just go, just like squid. All the rest of the signature, like. If I actually.
Oh yeah, Robbie's right. I'm going to. I wasn't finished. Cosby,
Man, he's right.
Robbie's my old 2x squared.
Unless for both.
Well, that was
5x.
What did you
No, it's not.
All right, walking around, I say we did pretty well on number 3. Okay, check it out. If you plugged -1 into the g function, you'd get 3. And then if you take that answer of 3 and plug it into the p function, which happens to be a fraction, we get 5/0, but we don't want our eggs on the bottom of our shopping cart, so that would be undefined. Did we do okay on 3? Okay. Walking around, though, we do have to talk about 2. Okay, because if you plug in -2 into the f equation, there are a lot of parentheses and a lot of negatives, which is where some of us can get kind of tripped up when we do our order of operations. If you think about the order of operations, parentheses and exponents come first. So we have both of them actually happening in our first term. If you take -2 squared, okay, -2 times -2, that's a +4, but then you have the additional negative out front, which is going to change it to a -4. Okay, so -2 squared is a +4, and then the negative out front changes it to a -4. 3 times -2 is a -6, -5. Altogether, we have a -15. For p of 2, we'll get 4/-1, which is -4. So we have the 2 separate answers. This notation's asking us to add them together. So -15 plus -4 would be -19. Okay? Most of our mistakes, if you did make it, was with this term. Be careful with the squareds and the negatives. Okay, order of operations. Do we got to talk about 2 or 3 anymore? No. Further? All right. We're going to amp it up a bit. Okay, take a look at the next few. So, up to this point, we've really only been looking at function notation with a number. Like if we were plugging in 4, 0, 1, whatever the case may be. If you look at our first example at the bottom of the page, it's asking us to find f of x plus 3. So it's no longer just a number on the inside of that function. We now have some variable to also take into consideration. What do you think this is asking us to do? Maybe think about if it was a number, what would you do? Might help you out. What do you think, Matt?
Plug in x plus 3 for all the x's.
For all the x's in the f function. Okay, so if you take a look at the f function, instead of just having an x in there, we're going to substitute in an x plus 3 using parentheses. It might get messy, yeah. But we can do it. So instead of every x, we're going to substitute in that expression, okay, x plus 3. We're going to try to simplify it, meaning expand it, get rid of the parentheses, maybe combine some like terms. Okay, we want to see what we would get out in the end. So if we start kind of reading our expression that we have here, remember order of operations, parentheses, exponents come first. This power of 2 means what? What can we do with that power of 2? How can you figure out x plus 3 squared? Go ahead, Hadley. Multiply it by itself. Yep, write it twice. I think I told you guys that was the mistake that people make, sends a chill down my spine, that they want to distribute in the 2. Okay, it doesn't work that way. So we can write that twice. Let's say we want to keep working across the expression. If you want to, we can distribute in the negative sign next. And we'll still have the +3 on the end. You can approach this simplification process any way you want. Okay, it's just what you're comfortable with doing. We just got to make sure that we can get the correct result in the end. Let's see. So right now I still have some parentheses on my paper. Okay, order of operations, those come first. We will go through some FOIL process to multiply those together. So firsts, outsides, insides, lasts. If I continue to look through my expression, I see a -3 and a +3, so those will cancel, and I'm left with a -x. All right, I'm kind of running out of room, so I'm going to go to the one underneath it. I still have parentheses, so I'll distribute in the 2. Okay, some of you may have wanted to combine the like terms on the inside first. That's okay. Okay, there's more than one way to go about this, but we should all get the same thing in the end. So now that all of my parentheses are gone, we can combine our like terms. We'll have a 2x squared, and then I have 6x, 6x, -1x, so that would be 11x, and then an 18. So we're stepping it up a bit. Instead of substituting in a number, now we're substituting in an expression, meaning that there's a variable in there to take into consideration. Are we doing okay? Okay, we're going to stop there for today, but notice how they're eventually going to get good, meaning nice, okay? We'll check those out tomorrow. Yeah.
Is this as far as we have to go? Houston Jones, who actually
So funny how like you didn't even realize you just talking about the
She was like, so then you guys got this, and I was like, yeah. I didn't realize I was doing
it's just 2 A's like 20. Oh, it's doing I divide all the points and now.
Oh my god, I fixed it after I already
Oh, let's go, boys.
How many people?